Prakash. Today I am discussing about probability theory and statistic process. Today my topic is about random processes, probability theory, probability theory. How deep with the certainty? Random process, the temporal characteristics definition. Definition. A random process or a stochastic process. The another name of a random process, stochastic process. This is a process in which a random variable depends on both time t and time t and sample space as. Here, time t, how the variable change over the time. And the sample space as the random outcome from the experiment. So a random process is written as x of smallest comma t and or simply x of t. We can written here s represented the randomness, simple point, sample point, t represent time. That means for every random outcome s, we get a different signal. So for every s outcome, we get a different signals of a function time, function of time t. For a function of time t. Next, there are different forms of a random process. Let me discuss one by one. When time t is fixed, when time t is fixed, you only look at the particular instant of time. We look at the only particular instant of time. The random process becomes a random variable because only randomness remains represent as x of s comma t1. This shows the random value of a process at a time t1. Uh, means a time is fixed, that way we get a time t1. Time t1. And, for example, noise voltage of a measured instant, but many different each time. But many different each time. They repeat the experiment. You may differ. You may differ each of time. You can repeat the experimental. You can repeat the experimental one by one. And next, when the sample space S is fixed, then the sample space S is fixed. You are looking at both particular outcomes of one experiment. One particular outcome, we get, it becomes a real function of a time. That only particular value becomes uh, it becomes a real function of a time as it represented in mathematically capital X s1 comma t. This means for one specified experiment s1, how the signal changes over a time. It means a specified experiment S1. The signal changes over a time. It will changes over a time. Example, the waveform of a realization the waveform of a realization of a random variable of a random signal, like one recognition noise. And next third one, when both the t and both the time t and the sample spaces are fixed. Here both the time t and sample spaces are fixed. Both are given specific values, so it becomes a constant. It will become constant. It represented as capital S1 and T1. Example, the value of a signal at a specific instant in a one experiment. This mathematical formula, these two are constant, T1 and T2. Yes, T1 and T1, these two are constant. These two are constant. Sure, constant. And the value of a signal at a specific instant in one experiment. The value is specific in a one instant of one experiment. It will perform only one experiment. And next, summary of a random process. Summary of random process. Summary of random process. Condition. Time variable sample space. Time variable sample space representation cap x of s comma t. Nature random process. Example random signal. Condition time fixed. Capital S of S1 comma T1. Nature random variable. Example noise at a particular instant. And a sample fixed. Capital S1 and T1. Time function. Example noise waveform will be occurred. Both fixed. Capital X of S1 and T1. It will be constant. The signal value will be occurred. And the next classification of a random processes. There are four types of random processes. We will discuss one by one about classification of random processes. Number one, continuous random process we call as CRP. The time variable of a continuous random process is continuous. The random variable is continuous. For example, voice signal and terminal noise will be occurred. For the discrete random process, time variable is discrete and random variable become continuous. It will be measures daily temperature readings and a continuous random process sequence. Third one, continuous random sequence. A time variable is continuous and the random variable become discrete. The random variable become discrete. Switching between discrete states and continuous. For a discrete random sequence, time variable is discrete and random variable also become discrete. Distant data coin counts outcomes times. And the next classification of random process. A random process can be categorized based on whether time and the amplitude of a random variable are continuous or discrete. Accordingly, they are divided into four main types. We will discuss that four main types and also the waveforms of a both continuous and discrete. Also, we can see uh, by this classification of random variables. First one, continuous random process. First one is continuous random process. A random process is said to be continuous. A random process said to be continuous if both time and the random variables are continuous over a entire duration. Both time and the random variable are continuous. Time and random variable are continuous. Okay. Here, time and random variable are both continuous. Entire the duration, entire duration, and this type of a random variable can take any value within a continuous range. This is a type. The random variable can take any value within a continuously range of all moments of time. Here an example of fluctuation of a noise voltage in an electrical circuit. This is a noise voltage of a electrical circuit, noise voltage of a electrical circuit. When we talk with a microphone or a speaker, the noise, the noise from the speaker or a mic, it will become, it will be occurred like this structure, some upwards and some downwards direction like this. We occurred. The fluctuation of a noise voltage in an electrical circuit. It will mainly occur in an electrical circuit when both time and amplitude were continuously continuously. And second one, discrete random process. Discrete random process. In this discrete random process, the random variable takes discrete values only, but time is continuous. Here, here is discrete, and time was continuous. And time was continuous here. The random variable can be switched only between certain fixed levels with a process continuously. Progress continuously. For example, the digital signal that alternates between two discrete levels, such as positive and negative levels. So we can see here this is a negative part and this is a positive part of this signal. So this is a negative and this is positive. Positive, but it exists continuously in a time. It will occurs in a time only. And last third one we will discuss. This is a continuous random sequence. The continuous here this is a continuous random sequence. So in the last hour we discussed continuous random processes CRP, and next we discuss a discrete random process. DRP. Now we will see continuous random sequence. Continuous random sequence. Continuous random sequence. A continuous random sequence occurs when time is discrete. Time is discrete, but the random variable is continuous. Actually, the random variable also variable is continuous. The random signal is defined as a specific time interval. Here, the random signal is defined at a specific time interval, but its specific, but its amplitude can take, but its amplitude can take any continuous value. It represents as a set of random variables defined solely for a discrete sampling instance such as t is equal to 0, comma 1, comma 2. This is the type of often used when sampling a continuous signal with a equalizing its amplitude. So here is the waveform of a continuous random variable. The starting from negative side, it's also up and downs. It will occur. It traveling in the axis of time. Um, this is a type of often used sampling a continuous signal with a equalizing its amplitude. Equalizing its amplitude. Here this is about continuous random sequence. Sorry, I am forgot write discrete random variable. Last. So overall, we discussed this today. Uh, First, random processor and types of random process and random and temporal characteristics of a random processors. Okay, thank you. Thank you for your